Welcome to this training session on the key new features in HAP version 6.0. We are going to focus on 10 key new features. We will overview each one so that you will be familiar with the major technical features in the new software. Additional training courses from Carrier are available with much more detail that will prepare you to use HAP version 6. Think of a key new feature as a technical addition or enhancement that incorporates wholesale new amounts of data, concepts, or design that differs from existing HAP versions. Notice all the key new features we are going to discuss are marked with an asterisk. That means that feature is also covered in another HAP version 6 video training session available from Carrier. In many cases, the more detailed training session will demonstrate use of the actual HAP software to explain the feature. What you see here is not the whole of what's new in HAP version 6. There are literally dozens of other new features in addition to these key new features. We will list those other new features later in this training session. First, there is updated and enhanced weather data. There is new design weather data for running loads for 7,400 sites worldwide from the latest ASHRAE Handbook of Fundamentals. This is up from approximately 820 sites in HAP version 5.11. Simulation weather data has expanded from about 585 stations in existing HAP 5.11 to 7,400 stations in version 6.0. In addition, for most stations, there is now a one-to-one pairing made by the software between the design station and the simulation data. Next, there's a new graphical method of choosing the station you want for weather data. The software automatically loads the 10 closest stations to your project site with paired design and simulation weather data sites, no matter where you are in the world. As an example, here are the choices for a building site in Scranton, Pennsylvania, USA. The markers you see indicate where a weather station exists. When you click on one of the 10 choices, the marker you select turns green. You no longer need to select simulation weather separately. HAP version 6 gives you the ability to choose comfort design weather data, 0.4%, 1 or 2%, or dehumidification, also called dew point weather data, 0.4, 1 and 2%. Dehumidification weather data is also used to determine the impact on total load for equipment sizing. Design engineers working on a project sensitive to resulting space relative humidity and/or large outdoor air amounts, especially in humid climate regions, will often use the dehumidification data to run the cooling load and compare that load with a run using normal comfort design conditions outside. If the resulting load is much larger, they may factor that increase into the final equipment sizing. This exercise is obviously quickly accomplished now in HAP version 6. Next, there is heating design, 99.6 or 99% data. Overall, the choices of design weather data, as you can see, have been greatly expanded from existing HAP versions. Users can always choose to input their own user-defined design weather data as opposed to selecting any of the design or dehumidification choices shown here. Also, notice the outdoor CO2 level is now part of the weather data, not the air system. Finally, the ASHRAE 90.1 climate zone number is automatically displayed as part of the weather data. This comes in handy for selecting building envelope construction and other climate zone dependent items. I have highlighted the major areas in HAP version 6 weather properties screen where all the new changes and additions have occurred, as shown here. Engineers are very passionate about using the latest and most applicable weather data for their project. Weather data is a foundation feature that impacts all phases of project design. The updated and enhanced weather data in HAP version 6 is a major key new feature in that respect. Next is the key new feature number 2. It is called New Building Modeling Workflow. Actually, this new workflow topic incorporates key new feature number 3, 4, 5, and number 6, as I have highlighted here. In the process of covering the New Building Modeling Workflow topic, we will be ending with number 6, a 3D rendering of the building. As a way to appreciate the new HAP version 6 workflow, we will review the current workflow in HAP 5.11, which is applicable to earlier versions also. That is what is shown here. Number 1, the HVAC engineer receives floor plan drawings from the architect showing the rooms and spaces. Number 2, using a scale, the engineer may do a manual space-by-space takeoff of the dimensions by measuring then taking note of the height, etc. Number 3, the engineer creates a table of the spaces with areas, orientations, space types, names, etc., so each one can then be entered into HAP. This can also be done with a CAD-based tool that either allows measurement of lengths and widths in the CAD or BIM drawing or directly gives the enclosed areas. But to enter the actual spaces into HAP 511, the traditional way involves organizing the data first into a table or spreadsheet and then entering it into the software. Number 4, the traditional space creation method requires the user enter the data for the 7 tabs shown here under Space Properties window. The General tab requires floor area and ventilation amounts. Then onto each of the remaining 6 tabs: internals, walls, windows, and doors, roofs and skylights, infiltration, floors, and partitions. The second tab, called Internals, requires entering lights, task lighting, electrical equipment, as are plug loads, people, and miscellaneous sensible and latent loads. These internal load components are then linked to their respective schedules and profiles. Now, we're not going to go to any further and discuss all 7 of these tabs, but we have made the point that tabular space creation from drawings can be quite detailed and consumes time. A 7-space project, as shown here, is not a big project, and you could always duplicate the first space and make changes for the next space if that helps the process go quicker. 7 spaces times 7 tabs would equal 49 windows of input data. When you are done with space inputs in step 5, you can manually check inputs and data printouts for each space. At this point, let's contrast this tabular approach of space creation in existing HAP 5.11 and earlier versions with how HAP version 6 will accomplish it. The new HAP version 6 building workflow, as shown here, also has 5 steps. Number 1, import architectural floor plans. Number 2, sketch over to create spaces. Number 3, auto-generate areas and orientations. Number 4, implant the spaces in a spreadsheet grid. Number 5, render the building in 3D. Let's discuss each step now. Step 1, you import the architectural floor plan images into HAP version 6. Each level or floor in the building is imported separately. These images can be of any of the popular file formats such as PDF, JPEGs, TIFFs, BMPs, etc. You can even import a screen capture from your clipboard. So for instance, if you were in a CAD program viewing a floor plan, you could create a screen capture and import that clipboard image into HAP version 6. Step 2, once the floor plan images are imported, you define the scale and the orientation. HAP knows how to interpret lengths of lines or rectangles. Then you sketch over the imported floor plan image by outlining the spaces. No previous CAD training is required, nor is there any special equipment required. Just your standard mouse. The sketch-over process continues until all spaces are defined. Using your mouse, you can place windows and doors directly in the perimeter wall floor plan. Once the sketch-over process and placement of all windows and doors is complete, in step 3, HAP takes the sketch-over dimensions of all spaces and uses the floor-to-floor heights, etc., to extrude the building into a 3D rendering, along with computing all the space, floor, wall, window opening, door openings, and roof areas and orientations. We will look at a typical 3D rendering in just a bit. After sketching over the spaces, where do they go? The answer is into the Carrier Design Spaces grid. Step 4, the Spaces grid. It organizes each space created by sketchover in a separate row with all the available ASHRAE defaulted space inputs, lights, plug loads, people, ventilation, etc., all organized horizontally with column headings along the top. The scroll bars or your mouse allow you to move left or right, up and down within the grid, with similar functionality to a spreadsheet program. This one, however, was designed by Carrier for version 6.0. The grid has all the capabilities to filter and sort spaces and do global space changes and other functionality to increase the efficiency of space configuration. But there's an additional feature that the grid design incorporates, and we should discuss that now. It's a concept called the space model. A space model is the total collection of both conditioned and unconditioned spaces that comprises the whole modeled building. A space model is comprised of all the space types, zoning configuration, and assembly assignments for exterior envelope and interior construction of the entire building. For example, an office building is never comprised of 100% office spaces. There could be corridors, conference rooms, restrooms, break rooms, storage rooms, a lunchroom perhaps, or a kitchenette, and of course office spaces. Each office project will have a different mix, so will have a different space model. Many of us have been using space models for quite a few years and are not even aware of it. For energy analysis, we often compare a proposed building versus the baseline version, which is almost the same as the proposed, but may vary in certain areas like overhead lighting power density and window construction, just to name two typical ones. With that in mind, the proposed building would have a space model and the baseline building a slightly different space model. In step 5 of the new workflow, the sketch over dimensions of all spaces are used along with the floor-to-floor heights, etc. to create a 3D representation of the building. The 3D rendering can be rotated with your mouse to examine the orientations and views for an overall visualization and inspection of the building. This is especially valuable on multi-floor building projects. One example is potential misalignments between floors in the PDF would show up in the 3D rendering and then could be corrected. At this point, I bet you agree this new 5-step workflow, including space creation, is a major key new feature. Before we move on to heat balance topic, keep in mind existing version 5.11 will remain in your HAP arsenal with the traditional tabular approach to space creation. But in HAP version 6, the tabular approach will not exist. Instead, the graphical method of space creation we have been discussing will be used. Number 7 key new feature is the heat balance method. It impacts the load and that impacts the energy calculations in HAP version 6. First and foremost, heat balance is not a new method. It's just the opposite. It's one of the oldest methods in the industry. Heat balance for a time wasn't practical due to its complexity. Calculation times were also an issue, but with new software implementations, it is now more practical to use heat balance on modern desktop and laptop computers for HVAC design. The transfer function method will remain as the method used in HAP 5.11 and previous versions of HAP. It is a somewhat simplified computerized method, as is RTS, Radiant Time Series, relative to heat balance. Radiant Time Series was not used in HAP 5.11 in earlier versions as it didn't lend itself to performing energy modeling like transfer functions do. This became increasingly important as more and more users required energy modeling capability, not just load calculation. Both transfer function and Radiant Time Series methods are not considered as accurate as heat balance. Heat balance is considered more faithful to building physics than other methods. What does that really mean? It means heat balance models building heat transfer closest to reality in commercial buildings. Most importantly, heat balance results in a wider range of applications, as we will see. Heat balance is considered the gold standard for performing load and resulting energy calculations in our industry. What makes heat balance more faithful, hence more accurate for building heat transfer? Heat balance equations are written for all outside surfaces, inside surfaces, and the air mass in the room. To do that, consideration is given to all the conduction, radiation, and convection processes going on in those locations on all their surfaces simultaneously, in addition to accounting for the storage effect and re-release of energy over time of the calculated building mass. In real buildings, all spaces are thermally interconnected. Every space has an effect on a neighboring space. Heat balance calculates this thermal connection. Transfer functions do not. Using transfer functions in HAP 5.11, if we ran the cooling load on the interior space shown here, we would include the interior heat gains like lights, people, and plug loads. There would be no glass or exterior wall solar in our interior analysis. That's because there are no windows or exterior walls in the interior space. But in real life, the solar on the perimeter does make its way into the interior zone by conduction, convection, and radiations. This creates cooling load in the interior open plan area. Heat balance in HAP version 6 models the impact of the perimeter solar heat gain on the interior as it really happens. That's the thermal interconnectivity that we had mentioned. There are quite a few additional applications in HAP version 6 resulting from heat balance. We have already discussed numbers 1 and 2 as shown here. Additional ones are heated-only spaces, cooling-only spaces, unconditioned spaces, attic temperatures, ceiling plenums, ceiling return plenums, raised floors, and finally flat or shed or gabled or hipped roof modeling. Remember we said earlier heat balance increases the range of applications? Next, let's discuss key new feature number 8, integration with U.S. Department of Energy, Energy Plus. Energy Plus is a powerful industry-recognized whole building energy simulation engine, computer program, that is used to model building energy consumption. Its continual development is funded by the U.S. Department of Energy's Building Technologies Office. Carrier has chosen certain Energy Plus features to integrate with HAP version 6, such as self-shading of the building, daylighting, VAV reheat box dual maximum control, water source heat pump variable speed loop pump control, DOAS supply air direct to space or to the terminal inlet, DX air systems 2 to 8 stages of control, and multi-speed supply fan control for air systems and terminals. This list shows where integration with Energy Plus made sense for HAP version 6. Let's take a minute and discuss the first new feature from Energy Plus, self-shading. Building self-shading is a powerful model that has been added to HAP. Self-shading automatically calculates shading on one part of a building by another part as shown here. That shadow will move across the building walls, roof, windows, and doors based upon the sun's position, impacting loads and energy consumption. This capability was made possible by the integration of HAP version 6 and Energy Plus. Now let's discuss key feature number 9, daylighting. Daylighting is defined as the practice of locating windows and skylights so that natural lighting from the sun can assist in providing effective internal lighting. The sunlight can be direct or indirect. The object is to reduce energy use of the artificial lighting while maximizing visual comfort. Daylighting sensors are positioned to dim the artificial lighting such that together with natural lighting, acceptable lighting levels at the work surface will result. Dimming of the artificial lights reduces their power draw and reduces heat gain from the lighting itself, resulting ideally in energy savings. The daylighting model in HAP version 6 supports these 4 popular daylighting strategies: side lighting, stacked side lighting, clear-story windows, and skylights. The primary purpose of the daylighting model in HAP version 6 is to demonstrate the savings of including daylighting on a project versus no daylighting, and to support compliance with ASHRAE 90.1 and LEED requirements. It is not intended for glare analysis or to optimize the daylight sensor placement. At this point, we have arrived at our last key feature. This one was included on the list, but is different from the rest. It isn't a brand new technical feature like the others, but it is important and the HAP user base needs to understand it. What exactly can be brought forward from existing HAP 5.11 to new HAP version 6? You will be able to convert schedules, walls, roof, windows, doors, shades, chillers, heat rejection, boilers, electric rates, and fuel rates. While this represents a sizable segment of data in HAP 5.11 projects, we cannot convert whole projects to the new version 6. The reason for this is HAP version 6 utilizes a 3D definition of the building envelope, including walls, fenestration, roofs, etc. This requires the relative position of spaces to one another to be known, along with the three-dimensional coordinates of all the surfaces, information not available in HAP 5.11 project. By knowing the relative proximity of all the surfaces, we can calculate the simultaneous heat transfer between all surfaces in the building per the heat balance method. This 3D modeling process is a totally new way to define the building data, which was not possible in the previous version of HAP. As a result, space data and elements that depended on spaces, like systems, plants, and buildings, are not compatible with 6.0 and hence cannot be converted. We already discussed the list of HAP version 6 applications resulting from the use of heat balance, and also the list of new features resulting from HAP 6 integration with Energy Plus. So lastly, here's a list of new features from Carrier Software Systems. Number 1 and 7 we already discussed earlier as key new features. Number 2, unlimited zones per air system, is a great addition, as is number 3 and 4, reheat coil modeling, and also number 5, direct exhaust at the space level. At this point, we have completed an overall discussion of HAP version 6. Remember, there are additional courses that exist on the Carrier University website with more detailed HAP version 6 training. For access to the additional training videos, select the HAP Training Videos link accessible through Help in the HAP version 6 interface. That concludes this training on the key new features in HAP version 6 software.